All right, this video is to go over the operations on vectors that we did not get to in yesterday's lesson. So yesterday we talked about operations on complex numbers, and what we're going to see is the operations on vectors are very similar, but they're completely different things. So what you need to be able to do by the end of this video and this lesson is you need to be able to add and subtract two vectors, and we need to be able to multiply a vector by a scalar. If you look at the whiteboard in the classroom, this is what the standard tells us that we have to be able to do. So before we start working with the vectors, adding and subtracting and multiplying by a scalar, we need to know what in the world that means. So a scalar is a quantity that is described by magnitude or numerical value alone. And so really this is just a number. For instance, like 3 or 1/7 or 15. These are all scalar values. They just have a magnitude. However, a vector is a quantity that is described both by a magnitude, like a scalar, but it also has a direction. So you'll see, if you remember Despicable Me, Vector actually made a math joke in the movie. And that was why his name was Vector. So we have some forms of vectors. There's actually more than just this one, but for Math 4, we're only worried about the component form. And the way we'll represent the vector is you'll use a lowercase letter and you'll put a little arrow over it pointing to the right. Or if you're typing, you can use it and just bold that lowercase letter. However, all in all, what a vector is for this component form is if we're looking at the coordinate plane, we're going to start the vector at the origin 0, 0 right here. And we're going to define the vector basically by its end point out here at some point on the Cartesian plane. And so these work very similar to x and y coordinates. And what that's going to do for us, it gives the vector a magnitude, which would be the length of this line. So this is my magnitude. And the direction of it would be this angle here. All right. Now, we're not going to actually deal with the numbers for magnitude and the angle, but that is a different form of vectors. All we're going to do is work with the component form. So we understand all of our vectors to be starting at 0, 0. So let's see what it looks like when we add and subtract vectors. So if I'm given two vectors, let's call them AB, or A comma B, and C comma D, where A, B, C, and D are all real numbers, then the addition and subtraction are defined as follows. Essentially, I'm going to take their corresponding parts, so the first coordinate of each vector, and I'll perform the indicated operation. Then I'll take the second part, or the second component of each vector, and I'll perform the indicated operation. Combined, these are going to form as a new single vector. So like in this first example, I'll take A plus C because those are the first components for the two vectors, and the indicated operation is addition, so I add A plus C. Then I say comma, I go back and I grab the second components, B and D, and I perform the indicated operation again, which is addition. And this forms a new vector that we call the resultant vector. So this is what we call a resultant vector. So these two here are what are called resultants. Some people, typically we just say, oh, well, it's the answer. But their actual name is the resultant vector. It's what results from it. So this is just our definition for addition and subtraction. So let's take a look at your handout and take a look at the examples for addition and subtraction. Okay. So let's take a look at that first example. We have the vector -3, 2 plus the vector 5, -1. So all I want to do is I want to take the corresponding components and perform the indicated operation, that is addition, and form a new resultant vector. So my first components in each vector would be -3 and 5, and I'm going to add them because that's the indicated operation. Then I would say comma 2 plus a negative 1. Right? Because that is my indicated operation. So if you're not sure where I'm grabbing these numbers from, it's not too bad. There's my negative 3. It's just coming down here. And so it's the first component. And then I'm adding that to the 5 because that's the first component of the second vector. And then I'm coming in and I am taking the 2. There's the second component of the first vector. And then finally I have, let's see, we'll go with this green. I have this negative 1, which is getting added to the 2. And the reason I'm using addition here is because my indicated operation was addition. So I'm using addition in both of these here. And now all I need to do is simplify it. So negative 3 plus 5 gives us 2. And 2 plus a negative 1 will give us 1. And that's all there is to adding two vectors. Let's take a look at an example for subtraction. So here I have the vector 2 comma negative 6 minus the vector 3 comma negative 4. Again, I'm going to combine my corresponding components, or the first components of each vector. So I've got a new vector. I have 2 and I have 3. My indicated operation is subtraction, so I'm going to subtract. My second components in each vector are negative 6 and negative 4. And I have to perform the indicated operation, subtraction, on them. So I'm going to simplify. 2 minus 3 is going to be negative 1. But minus a negative, I'm going to keep. Actually, it's not keep, change, flip. I'm sorry. I just turn them both to positive because negative times a negative is a positive. Negative 6 plus 4 is going to leave me with a negative 2. And so that is our answer. And that's really all there is to adding and subtracting two vectors. Now, that last expectation or learning objective is multiplying a vector by a scalar quantity. So given a vector u, and we're going to give it the vector components a comma b, just like we did for addition, and a scalar c, so this time c is not part of the vector, it's a scalar, so it's just a number, then multiplying a vector by a scalar is defined as, well, I'm going to show c times u. Remember, u is the only one that's bolded because that's the vector. Or I can write it as c times u with a little arrow over it, which is also equivalent to c times that component form. And what I do in that case is essentially, it's not really the distributive property, but it looks similar to it. I'm going to multiply both components by that scalar. So my resultant vector is going to be c times component A, comma c times component B. And here again, a, b, and c are all real numbers. And so my resultant vector is just multiplying the components by the scalar. Let's take a look at the example on your handout. All right. So we have negative 3 times the quantity 1 comma negative 2. So this negative 3 here is a scalar. I'm doing scalar multiplication. So that means what I need to do is I'm going to go ahead and multiply both components in here by the negative 3. So I have negative 3 times 1, comma, negative 3 times the negative 2. And I'm just going to simplify. So negative 3 times 1 is just negative 3. And negative 3 times negative 2 will become a positive 6. And so now I've scaled this vector by a value of negative 3. And that's all there is to multiplying a vector by a scalar. So hopefully you feel comfortable in adding and subtracting two vectors and multiplying a vector by a scalar. Now, let's go ahead and take a look at your Delta Math assignment and what it looks like in Delta Math. So as you can see here, you've got two skills. We have adding vectors numerically, And then we have multiply vector by a scalar. So let's take a look at this first skill, adding vectors numerically. So it says given vectors u, and it defines the vector in component form for me, -8, -6, and v, 1, 7, find the sum u plus v and write the result in component form. So basically it's just asking us to add these two vectors here. It wants us to find the sum u plus v. So we're going to take -8 plus 1, which gives us a -7. Then we're going to take -6 plus 7, because those are the corresponding components, and that'll leave us with +1. And then we'll submit our answer, and there we go. Now, when it comes to multiplication by a scalar, let's see if I can get that next one down here. What it's going to look like is this. It can say given vector v equals 1, -3, find -2 times vector v. So again, we're just multiplying both of the components here by -2. So -2 times 1 would leave us with -2, and -2 times -3 would leave us with +6. And that's it. So hopefully you understand how to add and subtract two vectors. Do your best on working on your delta math. And when you're finished with it, I believe you'll be at 58%. All right. So best of luck. Hopefully you've completed your handout. And you need to go ahead now and work on your delta math and make sure you've got these first 4 skills. I'm not sure on the percentage, but you need to have the first 4 skills done so that next week we can talk about matrices and we can wrap up the unit and take our test on this. Until then, I will see you on Monday. Have a great weekend, folks.